I am Dr. R. Akila, Professor and Head, Department of Artificial Intelligence and Data Science, Kamraj College of Engineering and Technology. So, greetings to everyone. Today the topic that we are going to see is topological sorting. The definition of topological sorting is, it is a linear ordering of vertices. So, here we are going to order the vertices in a graph, linear ordering, and this topological sorting is mainly used for directed acyclic graph. So, the meaning of directed acyclic is, as we know, this acyclic graph means a graph which does not contain any cycle. For example, you consider this is it is one of an example of a graph. So, A, B, C, D, 4 vertices are there, and I have the vertices in this manner. So, here in this graph there exists a cycle, that is A to D, D to C, and no, here there is no cycle in it. So, it is a directed acyclic, it does not contain any cycle. So, we can call it as a acyclic, and the edges are being directed. So, it is a directed acyclic graph. If suppose a graph contains, consider this, so if in this manner, if the edges are connected in this way, here there is a cycle exists between A, D and C. So, if it has a cycle, then this topological sorting cannot be applied for this graph. So, it is not as it contains cycle, it cannot be applied for topological sorting. So, this topological sorting can be used for directed acyclic graph only. So, if a graph contains cycle, we cannot apply this algorithm. And another way, and in the graph, if there is a path, when there is a path exists between Vi to Vj, then it means that Vj will appear after Vi. So, this is the entire definition. So, topological sorting is a linear ordering in a directed acyclic graph, and there should be a path from Vi to Vj such that Vj appears after Vi. Okay. So, in this case, this is the entire definition. So, let us solve this topological sorting by using an example. So, let me take this graph. Here I have a graph with 4 vertices A, B, C and D. There is an edge from A to B, A to C, and B to D and C to D and B to C. So, this is a graph. I am going to solve it by using a topological sorting. So, first thing that I have to consider is whether it has any cycle or not. If it has a cycle, then I can't apply topological sorting. First, let me check whether there is a cycle. No, there is no such cycle, I think. So, it is so for this graph I can use topological sorting. First step in finding out this topological sorting is to identify the adjacency matrix. So, I am going to draw the adjacency matrix of this particular graph. So, the adjacency matrix. So, as there are 4 vertices in this graph, here I am going to construct 4 cross 4 matrix. So, the vertices are A, B, C, D. So, here it is, I am going to make it as here. Whenever there is an edge from one vertex to other vertex, I am going to mark it as 1 in this matrix. So, here I have a vertex from A to B. So, here A to B is 1 and A to C there is an edge. So, A to C, yes, it has been marked as 1, and B to C, here B to C is 1, and B to D, so marked as 1. Is there any other edges? Yes, C to D. Is there any other edges from D? No. So, totally I have 1, 2, 3, 4, 5. So, 5 edges. So, I have marked this 5 edges. So, remaining other things are marked as 0. Okay. So, this is the adjacency matrix of the particular graph. Okay, here for in each columns, that is I am going to count the number of ones in each column. Here on this A it is 0, and the number of ones in the column B is 1. number of ones in the column C is 2, number of ones in D is 2. This number is nothing but the in degree. This number is the in degree of A. In degree of A is 0, in degree of B is 1, in degree of C is 2 and in degree of D is 2. So, what does it mean by in degree? In degree is nothing but the number of incoming edges, you call it as an in degree. Here in A, is there any, there is a, let us have it in some other example also, So, what are the, that is how many edges or incoming edges or to D? So, D is receiving the edges from A to D. A to D, it is having some edges. So, this one is called as an in degree, the incoming edges you call it as 1. So, the in degree of D is 1 and in degree of B, it is receiving the edges from A as well as from D. So, it is 2, the in degree of B is 2. Similarly, for C, so C is receiving the number of edges from D as well as from A. So, it is 2, the in degree of C is 2, whereas A does not receive any edges from any other vertex. So, the in degree is 0. So, in this way we can calculate the in degree from the graph, or we can calculate the in degree by means of constructing an adjacency matrix. So, after constructing the constructing the adjacency matrix, we can find out the in degree. Then we are going to find out the topological sorting. So, first let me write the vertices. So, how many vertices we have in the graph? 4 vertices. So, A, B, C, D. And here I am going to have an NQ. So, the definition of an NQ is, I am going to add an element to the Q, you call it as an NQ, and DQ, whenever I delete an element from a Q, I will be making as, I will be pushing the element in the DQ. So, the first, as an initial step, I am going to write the in degree of all these vertices. So, what are the in degrees? So, the in degree of A is 0. So, I am going to mark it as 0, in degree of B is 1, in degree of C is 2, in degree of D is 2. So, the first step I have marked the in degree of all the vertices, and the next step is I have to find out in which vertex the in degree is 0. So, the 0 comes under the vertex A. So, the A vertex has an in degree of 0. So, I am going to mark it as some, I am going to mark this A vertex, and I am going to insert this A vertex into the Q. So, I am going to NQ the vertex A. Okay. So, after writing this vertex A in the NQ, I have to find out the adjacency of A. Adjacency of A. What do you mean by adjacency? Here this A vertex, the adjacency of A is B and C, because these two are nearby. So, A adjacency is B and C. Now, I am going to reduce the value by 1 to the adjacency vertex. So, A, the adjacency is B and C, I am going to reduce the B and C by 1. So, already it is 1, 1 minus 1 0, and here C I am going to reduce by 1. So, it is 2 becomes 1, remaining as it is. So, after reducing the value of its adjacency matrix by 1, again I have to repeat the step, and this NQ, I have added this element and I am going to find out the adjacency. Once I will find out the adjacency, I have to remove this vertex and I have to insert it in the DQ. Okay. Then next step, I have to find out what is the, I have to repeat the step, what is the, I am going to find out in which it is 0. So, already A has been NQ'd. Other than that A, what are the remaining in degree is 0. So, it is here I have the B as 0. So, I am going to mark this B. So, I am going to write, I am going to NQ the vertex B. So, I am going to write the vertex B in the NQ. Okay. Then, after writing this B, what is the next step? I have to find the adjacency of B. What is the adjacency of B? So, B is here, what is the adjacency? A, C and D. So, remaining 3 vertices or its adjacency. So, I have to reduce the value by 1 to all its adjacent vertex. So, I have to reduce for A is already 0. So, let it be 0 and I am going to reduce the value of C by 1. C is already 1, again 1 minus, it becomes 0, and D, the D value is 2, it is now going to 2 minus 1, it is 1, and this value is being repeated again. After writing this B, I am going to NQ this B, that is I am going to DQ B. Okay. So, A has been NQ'd and DQ'd and B is also done, and my next step is, what is the remaining 2 vertices C and D. Among the C and D, which vertex in degree is 0? It is nothing but C. C in degree is 0, D in degree is 1. So, I am going to choose C. So, I am going to mark the vertex C and I am going to NQ C. So, I am going to repeat again. Okay. So, after C, I have to find the adjacency of C. What is C's adjacency? C adjacency is again A, B and D. So, again I am going to reduce the value by 1 towards adjacency of C. So, it is already 0, 0, it is 0, or C's adjacency is D. So, D is now 1, I am going to reduce by 1, so it becomes 0. So, now I have to just DQ. So, already this step is being left out. So, C is NQ'd and C is DQ'd and C's adjacency has been reduced, and now I am going to mark it as D as 0. Yes, here the D in degree is 0. So, I am going to mark it as, I am going to mark and I am going to NQ this value D. So, after NQing it, I am going to find out the adjacency, but it already the number of vertices all becomes 0. So, I am going to just DQ the vertex D. Now, we have NQ'd all the vertices in the graph and also DQ'd. So, it becomes the end. Okay. So, once all the vertices has been NQ'd and DQ'd, here comes your topological sorting. Topological sorting is nothing but the order in which the vertices has been DQ'd. So, what is our topological order here? The topological order is the order in which the vertices has been DQ'd. So, first my order is A, B and C and D. So, this is the topological order of this particular graph. Thank you.